So, in order to determine if we haven't taken enough measurements to sample a population, we can estimate the number of uh, total tests using the following equations as shown below. Okay, so the total number would be equal to the uh, t-score at this needed probability for a certain amount of degree of freedom times the standard deviation divided by d squared. Right now, d is defined as the precision value, which is equal to half of the confidence interval. Okay, so if we take the confidence interval that we want, all right, divide that by 2, all right, that would be the same thing as saying it'd be equal to tvp s of x over the square root of n. All right, just using that formula that's shown above. Okay, so in practice, what typically is done on a data set is they take n1 measurements of a variable to establish some type of estimate for what S1 is, all right, and the deviation, the confidence interval R, right? Based off of those initial measurements, all right, we can then use those measurements to estimate the total number of measurements required using the following equation here. Okay, so the additional number of measurements required would be equal to the total number of measurements minus the initial number of measurements taken. Okay, so the best way to show this concept is through an example. So if we take 21 measurements, okay, so our initial amount of measurements we take is 21 measurements, okay, the standard deviation of that data set was found to be 160 units, okay. We want to reduce the 95% confidence interval in the mean value, so the mean of our overall data set, to be about plus or minus 30 units, okay. So to help us determine that, we need to estimate the total number of measurements required, okay. So based off the data, right, there's a few things we can calculate right away. The first is the amount of degree of freedom, which is just equal to the total number of measurements we've taken so far minus 1, right? The second thing that we need to know is what probability are we interested in, okay? So we're interested in 95% confidence interval, so we can use p is equal to 95. Alright, we can also say the level of significance would be equal to 1 minus p, or 0.05, right? The other piece of information we need is the confidence interval that we're interested in, so we can calculate the precision value, which is just equal to half of it. So since we have plus or minus 30 units as the desired range of our mean value, alright, we can add plus or minus 30 here, alright, and that would give us our d value. Okay, would just be, instead of being plus 30 minus negative 30 would be minus 6, would be 60, divided by 2 would be 30. Okay, and the last thing we need to do is determine, for the given data that we have, all right, what is our t-score for the level of probability that we're interested in. Okay, so to do that, we can use the inverse two-tailed test, all right, where we plug in our probability that we're interested in. So the probability in this case for the inverse test is alpha, or the level of significance. That's what Excel uses. And then the degree of freedom would be just 1 minus the total number of tests run. Okay? And that gives us our nice t-score. Alright, and once we have our t-score, alright, what we can do is we can plug that in. Alright, so this is all the information that we initially need. Alright, and then the last, what we'll do next is we're going to determine what is the confidence interval at 21 measurements, okay, and the first thing we can do is we just multiply the number of measurements times the standard deviation, and then we take the t-score times the standard deviation, and then we divide by the square root of the number of measurements, and then we get 73 about units. So that's too high, it's not within our 30, so we need to determine what would be a total number. So to determine the total number of measurements we need is we take the standard deviation, we multiply that by the t-score, and we divide by our d value. Right, and when we did that, we got around 124 total total tests that were needed. So to determine the amount of remaining tests, we just need to subtract the current number of tests that we took, 21, from the total 124 to get 103 remaining tests. Okay, so this is how you can go about determining how many tests are needed to properly sample a population.